HVAC 360, episode number 44, BIM and Beyond. Hey, welcome back, everybody, to another episode of HVAC 360. I am your host, Matt Nelson. This week, I'm going to talk about a topic that kind of struck my interest a little bit recently. It's BIM. If you're not familiar with what BIM is, it is Building Information Modeling. Basically, it's a digital representation of the physical and functional characteristics of a facility. And basically, it's just kind of a way to, share knowledge. I think a lot of people have different, conceptions of what BIM is and, what you're supposed to do with it. Because, you can take a very limited view of BIM. And what I mean by that is that you can think about BIM only as a drawing tool to look at different systems and to produce an end product for a owner that is a sort of an integrated design. So, but I think it's a lot. There's a lot of information out there, and it's really a lot more than that, or it's the possibilities are a lot greater than that. Think about the expansion of just, where drawing has come from. And I kind of wanted to kind of step through that process with you a little bit to kind of describe it. The one thing you'll find out fairly early about BIM is they talk about the dimensions of BIM. And what they mean by that is basically, you have your two-dimensional drawings. You have a three-dimensional drawing, which becomes more of a representation of the building itself. It's not. You're not dealing with a flat 2D drawing. You now have a 3D model of the building. But they don't stop there. They actually add different dimensions above and beyond that. So you'll hear things like a 4D BIM model or a 5D BIM model or even a 6D BIM model. So in brief, if you think about the model, you got your 2 dimensions, 3 dimensions. That's pretty easy to understand. I think most everybody who's drawing building understands 3 dimensions. Okay, that's fine. So what's this fourth dimension? Where does that come in? The fourth dimension is actually more like a integration for construction, kind of a time schedule. So you can integrate time into the BIM model. So, okay, when you think about a Gantt chart, you have your predecessors and your successors and all those sort of links that link tasks. Like you can't put drywall before you frame a wall, or you can't put the structure up until you prep the site for the foundation work. So there's a certain sequence that it has to follow, and that's where the 4D, the time, comes in. So you can actually build this model, and then in practice actually say, okay, well, here's how it's actually going to work out in the schedule based on the parts that the model is made up of. So when you take a look at, that's the 4D, you take a look at 5D. 5D now adds a layer of cost estimation into it. So you can actually figure out, okay, here's what's actually gonna cost for so many doors or so many precast panels or light switches or pounds of ductwork, things like that. And the one interesting thing that you can do with that is you can actually, as you've extrapolated upon this time continuum, you can see how much money you're spending, as you're going through construction. So it's that's just one of the uses of the fourth and fifth dimension, so to speak. Because I'm kind of breezing through it. I don't want to belabor the point, but I just want to make you aware that these extra dimensions, when you talk about BIM, you'll start hearing these extra dimensions being mentioned. The sixth dimension, which is a particular interest to me, being a commissioning agent, or commissioning authority rather, is that it deals with the facility management. Really, it kind of says, okay, the 5 dimensions up to this point have kind of gotten the building built, and now let's take it into the 6th dimension and actually use that information to be able to maintain that facility. Because obviously there's a lot of information that's out there, and it's very useful to those facility managers. So let's step back a little bit, go back to the drawing board, so to speak, and talk about how this drawing process has kind of evolved a little bit. So you basically you started off with your drafting boards and your pencils, erasers, and all that, all those sort of accessories that you had, and that was basic. I mean, that was you had at the time you thought through things, because if you made a mistake and you did it in pencil, then you put it in ink and it was set. It was a lot of effort to actually make those changes. I don't speak from experience because I'm not that old, but I've talked to people who actually did that, and you really had to plan things out. And you can even talk to some of the some of the previous episodes with Jim Wickert, and that's what they had to live through. They got a background from an architect, a literal piece of paper, and then they kind of overlaid their stuff to say, okay, here's where it's gonna, here's where it's actually, my ductwork's actually gonna go. And they went through this painstaking process of actually getting everything down. But they did a lot of thinking and a lot of sketching ahead of time, and just it wasn't just kind of thrown on there just to get it on the drawing and then moved around afterwards. It was planned out, then drawn out, sometimes erased 2 or 3 times, and then finally they get the whole thing set up, and then you went ahead and inked the drawing. So when you moved into computers, a lot of different things happened. Now you're able to kind of replicate mistakes rather rapidly, because you could take something, say, as common as a detail. You wouldn't have to redraw the detail every single time. Not that they necessarily would before, but you could take that detail and you could put it on multiple projects, and it may not be applicable. There might be things there that refer to hydronic heat when it's an all-electric job. So you really have to be aware that those were some of the things that started working their way into design. And people thought, okay, great, computers, you're using computers now, you should be able to get these drawings out much quicker. Well, you know what, it actually made things worse, because now you couldn't sit down and think about laying out a job. Now you were actually going through and drawing, and the fact that the younger people, it was the younger generation that was learning how to use the computers, rather than maybe some designers who were older. Maybe they just retired and they didn't give these, they didn't educate the younger engineers as much as they should to be able to properly lay out a system before just starting to draw. They want to fill up the page. They want to make sure that they get everything down, and they think they have it. They have everything, and they just go ahead and draw, when you really need to stop and think about what's going to be important. Okay, I got to make sure that my path is right, that I have enough space, that I do some coordination to make sure that the structural components aren't going to be in the way when I run my ductwork. Things like that you need to make sure that you did ahead of time, that you needed to think about. And then you get into this whole 3D fiasco. And it's really great, but the learning curve is so hard, for some people, and frankly, I can completely understand. There's so much information that when you first start using these products that just come out on the market, there's so much information out there that you need to actually fill in. I mean, if you think about when you're drawing in a pencil. You draw a line or a couple of lines that represented a wall. That's all there was to it. Now you draw it in 2D. okay, relatively the same thing, but you know what? You could actually, you might not get it to the right scale. You might, draw it in the wrong place. You may draw it in a place that it doesn't line up with the rest of the people who are drawing electronically. You work into 3 dimensions, and all of a sudden you have to put a height into it. And if you're putting more and more information, all of a sudden you're saying, well, this wall actually represents something that's this thick, and it's made up of these components, and these components and materials cost this much. So you're really kind of there's a lot of things that go into this 3D version, this BIM version of a building. That's I got to be honest, when done right, is just like ooh you could do a fly through of a building, and you're like, this is unbelievable. You do it right once, and you just make certain cuts to get your floor plan all laid out, and you're done, and that's just incredible. But again, it goes to that attention to detail. That if you have basically it's garbage in, garbage out. The GIGO principle. Where you constantly are upping the ante when you go from paper to 2D computers, to 3D computers. I just got to stop here because this one story really, it is very poignant. When you're dealing with these computers, there was this one time we were drawing, and there was the power went out, and some of the older drafts people, they actually, or one person in particular, started nothing better to do, but he went around and he was selling pencils to some of the younger people. He's like, obviously it was a joke, but he's like, $5 for a pencil, just to kind of iterate the point that, it's kind of like, with these computer models, you have the computer and it's such a great tool, but, without power, without certain things, it really is kind of just a paperweight. Whereas a piece of pen, as long as you could see with a piece of paper, you could actually get down and put your ideas down on paper. And I think that with this whole acceleration of drawing and the margins being squeezed and less time being put down, I think that a lot of people are rushed in thought. And it's so ironic. I remember times when people would say, hey, you know what, this engineer, he's not doing anything, and it's like, well, you don't understand. It looks like he's not doing anything, but he's thinking. I mean, thinking looks like doing nothing, but you realize that, a lot of thought process has to go on when you're thinking about something and you're problem solving and you're trying to get things done. And sometimes it just looks like doing nothing, but it's really, you're doing those, very critical pieces, to solve the puzzle. So I think that the one thing that I always liked, whether it was actually pencil drawings or 2D drawings, things were it was even in the specifications. The drawings are diagrammatic in nature. You're not supposed to scale off the drawings. They're a representation, a communication of the intent of the engineer or the architect. Unless they have it, the dimensions, called out, you're not going to, pull out a scale and you're not going to measure the drawings. That was kind of the rule. But this thing it starts to, break down now. With the BIM model, you have the designers and the contractors, and you're trying to get this BIM process to flow, from the conceptual design all the way through the contractors. Because, and working for a contractor, you realize that, as an engineer, you're like, you draw a drawing and you're like, okay, build it like this. And, it's like, well, we're going to have to reinterpret this, this drawing to actually get, the details. Like you don't put in, you just, in some of the general notes, you say, well, put in a valve every time there's a branch, a main branch. Well, you don't draw it, but somebody has to estimate that, and the contractor has to get the quantity right to get it in place. Otherwise, they're going to do a bad job. So, there's a point where you're like, okay, well, do it the best you can. You can't do that in BIM. You really need to get everything on the drawing. You need to show where every little detail goes. And I think that a lot of people, especially younger people, may not necessarily know what all the little, details are. They relied on those notes to kind of get them through. And I don't necessarily know if there's a generation gap that people may not know exactly what goes on a drawing that had been covered by a note before. Whether it be like an access door to have some of those typical things. Every time you have a fire damper or a smoke damper, fire smoke damper, you need an access door. Those things are big general notes that people just take for granted. But when you have a BIM model, you actually have to put that, on the model. Otherwise, it's not going to get installed because it's actually what's going to be done. I've seen projects that go along, and I'll put a disclaimer in here, and maybe I should put this on the front end. I've never actually drawn in BIM. I mean, I've always just drawn two-dimensionally, and then when I started commissioning, I stopped drawing. So I never really drew in BIM, but I've been involved in projects that have used BIM before, and it's amazing because you still get that detail, the level of detail that's missing in the drawings. They only can take it so far. I've had when an owner wanted an as-built drawing with in BIM, the construction manager took the architect's BIM model and he threw out all the mechanical and all the plumbing and electrical, and they just started from scratch. They had the contractors redraw everything, and it's an interesting point. You feel like, okay, you know what? I mean, part of the point of BIM is not to do this double entry. It's to put the information in right once, so that you don't have other people, putting in the wrong information. But there's a lack of trust, and I think it's justified. There's a lack of trust in what an engineer designs and what a contractor can actually build. There's so many times, and I say this highest compliment an engineer can have as a duct design is to have it put in exactly how he drew it. Because typically, the contractor is going to find the optimal layout for that duct design, and they're going to install it like that, and it's going to be exactly what the engineer wanted or intended to do, but it's going to be in a way that's very cost effective. So they're going to be able to do that a lot better. I mean, basically, you should be able to do your sheet metal takeoffs and you'd be able to take it off your BIM model and put it into your plasma cutter, and you should be able to go to town to get the different dimensions for these fittings, and to be able to get the duct sizes and all of that, and you should be able to get that accurately off a BIM model. But engineers just don't draw like that. I mean, they never have drawn like that, and I think that there's going to be this this kind of evolution of how we actually draw, because there again you get away from the contracting and installing pieces parts. You go into the estimating, and there wouldn't be an estimator alive that I know that would actually trust an engineer to make sure that he had all the pieces parts in a BIM model, that he would just say, okay, well, this is all the parts that he had drawn, so that's what it's going to estimate it be. And they're not going to do that. They have this backlog of knowledge of putting things together, and it's going to be about so many bucks a square foot. And that's the way it's been done. That's the way it turns out. You can't argue with predictive, this experience that some of these estimators have. You just can't argue with it. So there's going to be this kind of transition from the engineer taking it all the way through these construction documents. I mean, and this is kind of where you hear these integrated project delivery. But I think people think of integrated project delivery as everybody kind of working in this, kumbaya kind of everybody get together and sing songs and get along. I think it's going to be different than that. I think you're going to have people working together, yes, but you're going to have people with different functions. I can envision it that an architect and an engineer, they come up with the general concepts. They come up with, okay, I'm going to put it here, and here's where the ductwork's going to be, and then they're going to hand it off to a detailer. Because realistically, you have somebody, a position that you're paying an engineering department. You're having them draw draw it up, exactly in BIM. When you have somebody that is going to have to estimate it, is going to have to construct it in a contractor's shop. If they're going to build, if they're going to make as-builts, they're going to throw away everything that an engineer does. They're going to take the intent. So I think that there's going to be this middle ground, ultimately this detailer that's going to be responsible. And this detailer, I think that his job function is going to be very, very specific. I think he's going to have a lot of actual construction knowledge. And he's going to have to, know exactly, how to draw in BIM. But he's going to have this practical knowledge to be able to put it all together, saying that, okay, well, the engineer wanted it like this. You're going to have, so many tons, and you do the cooling load, and you do the pressure drop, and you just tell me, what kind of, size piping and size ductwork that you want, and kind of the general layout, and start detailing it like that, because you have this double entry that's going on, that this is the efficiency that's being lost. If you think of design build contractors, this is something that is right in their wheelhouse. This is exactly the way they go to they'd go to market, because they would eliminate this middleman. Typically in design build, the engineers take it, put down on drawings just enough information for the contractor to feel comfortable with, and saying, okay, yeah, you know what, I've done this before, I can take it from here, and we have a price that we can agree on. Or if it's the same shop, they just go through and work it out. If they have any questions, they go to the engineer, they'll figure it out. So this is more what the integrated project delivery is going to be. You're going to have this engineer doing this high-end rough sketch kind of thing. You're going to have this detailer actually getting the model, building the model, and putting it together, and then you're going to have the contractor actually building off this highly detailed model. There's so many different things. If you think about BIM and what it's used for, I think some of the things is this interference. They talk about all the time. Frankly, interference is great, but you know what? How about the gaps? In like a building envelope. Where's the the missing insulation? Where do you account for things that aren't interfering but are not there? The detail that just isn't there. That can be all over the place. And if you're gonna rely, if you're gonna say that this is an 100% accurate detail, accurate representation of the building, you're going to have to put a lot more detail into it, and frankly, it's not worth it from the designer's standpoint, but it is of value to the contractor's standpoint. So there's going to be this this middle person that really is the detailer of the process. That's just my my guess, my prediction of the future is what it's really going to hold. So now I think we go to we've designed the building, and now we've get into this I think what is the most interesting and possibly disruptive portion of BIM. It's kind of to up until now the 3 dimensions, even the 4th and the 5th dimension, there's something that they're relatively they're being applied now. 3 dimensions clearly, 4th and 5th dimensions, with the time integration, the cost estimation. I think they're getting involved more and more. But now you come into the 6th dimension, and I really kind of lump like three different groups with this 6th dimension. I think you have the commissioning people, I think you have the controls people, and I think you have the facility management people. These are the actual people that actually make the BIM model, make it work. You can construct it great, but if it's rigid, there again, you want to be able to pass this information on in a very effective manner. And I think, when you talk about commissioning, one of the parts about commissioning is you go in there and you verify that, okay, what the designer wanted is what was submitted, is what was actually installed, and you have this process of verification. Well, you know what? I mean, that's taken care of, or holistically, really realistically, that should be taken care of already in the BIM model. The engineer has put in what he wanted. The submittal, maybe the CM puts in what the submittal was, and the contractor, actually verifies that they put it in, they have had it installed. I mean, there could be big portions of pre-functional checklists that just kind of disappear. They become a moot point. I mean, you go from this interference type of mentality to this coordination mentality to make sure there are no quote-unquote interferences between what the designer designed and put on the drawings and what was actually installed. You could see if the voltage changed along the way, and there would be some sort of flag that would say, "Hey, wait a minute! What you're putting bringing to the job site is 277 when you wanted 480." So there would be this kind of this flag already put in place with this information, this intelligent object that was put in during design. The information gets updated in the submittal, and and the installation kind of cements that and verifies that. So my question really is, this is such a game changer for commissioning. What's going to happen? I mean, technically, you could write a script for the controls, and it could do the functional testing for you. It could actually go through and say, okay, yeah, you know what, based on the sequence of operation, it goes through the paces, and it says, yep, it checks out. I mean, it's already, these type of things are already happening. I know I was just sitting down with a Siemens contractor the other day, controls contractor, and we went through the VAV boxes through a computer program. And really, there's nothing wrong with that. You get all the information that you'd want. What's the minimum? What's the actual minimum? What's the maximum? How's the heating valve doing? Are we getting, with a discharge air temperature sensor, are we actually getting the kind of discharge heat that we need off these units? I mean, all this information that you do in testing can be run, through a computer. Obviously VAV boxes, rather simple. But you know what? What's the next step? What's preventing, the programmers from programming, okay, well, we can do the same thing with, with all these other devices. I mean, obviously there's some, you still have some validation with actually watching, valve stroke and making sure the dampers, aren't loose. But, this is more of an inspection, a third-party inspection, that could easily slip through commissioning agents' hands. I mean, when I got into commissioning, people say, well, if the engineer did what he was supposed to do and the contractor did what they were supposed to do, would you have a job? And I had to look at him. I go, no. Frankly, I wouldn't have a job. But there's this gap, of the engineer's scope being cut back, and their fees being cut back. So they're doing, as much as they're paid to do, which is less than what it was in the past. And the contractors on the other side, really are losing that sense of pride. They're like, you know what? I mean, I need to make a buck. I need to get the job done. And some of them, I hate to say it, but there's even contractors out there who would say, you know what? I know this is wrong. They look at the engineer's drawings. I know this is wrong. I'm going to install it this way. Why? Because they're going to have to pay me to change it. Plain and simple as that. So you get this whole, this me attitude as opposed to this team mentality. But the BIM, starts to bring it all together, where you're getting this kind of this whole thing, this whole process, construction process, working along. And you know what? I mean, the O&M manuals, these are gargantuan beasts of just paperweights. I mean, it's just, these are atrocious. I mean, how usable are, the construction drawings and these manuals, these paper manuals, after they get delivered? They're not. But BIM has the information in there that if you kind of pull certain data out, you can actually get a pretty good O&M manual electronically. And this is something that's very valuable. I mean, can you imagine it? I mean, again, I was at the job site the other day, and the owner some of the facilities guys go, you know what? We're probably going to go back. We'll get the as-built drawings, and we'll pencil them up. We'll color them up, so we know exactly if something goes wrong in this area, it should be associated with this air handling unit in this system. How quick could that be done in Revit? How quick could that be done in BIM to say, okay, you know what, air handler 3's, is going to be in blue, air handler number 4 is going to be in red, air handler 5 is going to be in green. Guess what? You got that color coding done, you cut it, print it, hey, it's already there. It's just amazing what really can be done. But again, if you get these programs installed in the controls, what's left for the commissioning agent? Just to verify. Couldn't just anybody do that? Couldn't an owner's rep do that? I mean, I think you really have to think about and be cognizant about what this building information modeling is as things get more and more complicated. Obviously, I love complexity because that's really what causes my job. Things become really difficult, and it's hard for people to understand. And if you have this consistency from design through construction, I mean, ultimately, would it be a good idea to just be real close to BIM and say, hey, you know what, I'll handle this process for you all the way from design through construction. I'll make sure that all the information gets in there, all the information and documentation gets put into this BIM model. Ultimately, might that be a commissioning agent's job? Might commissioning turn into, a BIM authority? So, I mean, think about it. That's kind of out of the box, but really, it might end up being like that. And really, the only thing that I think about it is some of the biggest issues that we have with software compatibility. I mean, ultimately, that's where it's gonna stop. I mean, you have all these specialties where you have people with the estimating software, you have people with the drawing software, you have people with the facilities management software, you have people with the commissioning software, you have people with the project management software and the scheduling software, and all these different softwares all over the place. And there are, a lot of people that are working very hard to come up with this standard of what information, what should be, very, a standard as to what goes into software, what it should be able to do, how it should be able to communicate. If you're talking about similar to like the BACnet or the LawnWorks or whatever, on the controls side. But ultimately, that's what it's going to take. It's going to take some standardization because otherwise, these proprietary, and these are not cheap software packages. They're very expensive. Even to the fact that you get into some of the other details of who can afford BIM, but I think that that's really what it in the future it's going to boil down to is getting these things to work together, or somebody's just being this huge disruptor and saying, you know what, I'm going to do it all, and I'm going to do it at a reasonable price, and I don't care about everybody else. And being able to integrate piece by piece and just stepping forward and gaining momentum. And the last little thing that I'll talk about is more or less, you talk about the big clients versus the small clients. There's so many more small buildings than are big buildings. BIM is something that once people adopt it wholeheartedly, it'll become something that's going to be easy to design a project in BIM. They're going to have everything figured out. They're going to be able to do their load calcs in BIM. They're going to be able to do the pressure drops in BIM. It's going to be so much easier if they get the system to work smoothly. But there again, even for the smallest projects. But how do you handle that low end? Because, with BIM, if you talk about that sixth dimension with the facility management, yeah, you get to that low end of building. And I mean, I'm not talking, small building. I'm just talking about, like one-shot deals, or even if you talk about, small municipalities or small school districts where they don't have that kind of money to throw around to spend, $10,000 a year on these software packages to maintain this. It's going to be crucial that we get something that's going to be scalable down to a small level, that even the smallest consumer can benefit from that. And I don't see that. I mean, right now you're talking about these higher ends, these fourth, fifth, and sixth dimensions of BIM, and you're talking about major players. You're talking about people who charge the $5,000 a seat for a piece of software to really be able to handle it. I mean, they can do amazing things. But, Joe Bob down at the local school district isn't going to want to hear about, all the fancy bells and whistles. He just wants to know how to take care of his equipment when it's time to do the maintenance, and if he can get notified. I mean, there's some basic things that need to happen. And there you get, what happens on that low end. You lose some of the customization, the standardization, or who's going to build for that. So that's kind of my my 2 cents. Ultimately, it's going to end up, and this is, I guess, where it really concerns me, is what is going to be the standard of care in the future? What is the industry? What is going to be the standard in the industry? As more and more people do BIM, as more and more people perform the building modeling, get the information in there, get better and better at this. Is that gonna be the standard of care then? I mean, in the legal terms, is this something that everybody's going to be held to? And I guess I just use that as a fair warning to say, hey, you know what? I know you might not be interested in BIM, but you may want to take a step and figure out exactly what your career path and how it intersects with BIM, and how you might be able to leverage that or use that in the future. Because it's something that you should be able, you should know about. It really is it is the future of building. And whether or not what exactly it's going to look like in the future, I don't know. What are the job descriptions going to be? I don't know how AE firms are going to actually interact with the contractors and the CMs. It's kind of all up in the air. But I think that you should definitely be watching it in the future. So, I think that's enough of that. If you liked what you heard, let me know. If you didn't like what I heard, give me some suggestions. Fill me in. Shoot me an email, matt@buildingx.co. Go to the website, buildingx.co. And if you want a piece of the newsletter, I kind of sent out some tidbits of what you might have missed, what you and some other things that I find interesting throughout the month. Publish it monthly, and just kind of give you a little bit of details, a little bit of nuggets here and there. Not too detailed, but if you're not checking the blog on a regular basis, you might want to sign up and get that delivered to you. So. Otherwise, you can check me out at on my Twitter feed @BuildingX, or you can connect with me on LinkedIn. Love to hear from the listeners always, and that's pretty much it. So enjoy your week, and we'll talk to you again. So until next time, remember, know what you build and share what you know.